So in this problem, we need to check whether these three vectors are coplanar or not. Okay, let us begin. First, what we'll do, we'll name the three vectors. So let us suppose that a vector is represented by I cap plus j cap plus k cap. Then we have the vector b. The b vector is going to be represented by 2 times I cap plus 3 times j cap minus k cap. And then we have c vector. So c vector is going to be represented by negative I cap minus 2 j cap plus 2 k cap. Now, if we want to check whether if these three vectors are coplanar or not, we have to first assume that they are coplanar. So we will suppose that let a vector, b vector, and c vector are coplanar. Now, if they are coplanar, then it immediately tells us that if we pick up any vector, so let's say we pick up the vector b, we can always express it as a linear combination of the other two vectors. That means we have x times a vector plus y times c vector. This has to be true if a, b, and c are coplanar. So we are starting with this assumption that a, b, and c are coplanar. So that means this particular equation holds true. Now what we'll do, we'll substitute the value of b vector, so that's 2 times I cap plus 3 times j cap minus k cap. This will be equals to x times a vector. So we'll multiply each terms with x on the right hand side of vector a. So we have x I cap plus x j cap plus x k cap. Now this is going to get added to y times the vector c. The y times the vector c means negative y I cap minus 2y j cap plus 2 times y k cap. Now we will be combining the like term. So we have x minus y times I cap added to x minus 2y times j cap added to x plus 2y times k cap. So this is the vector 2I cap plus 3j cap minus k cap. Now we'll compare both sides. So comparing both sides, this is going to give us x minus y equals to the 2. Then we have x minus 2y, so that is going to be equals to 3. And then we have x plus 2y equals to negative 1. Now what we'll do, we'll label this as equation number 1, equation number 2, and equation number 3. Now the strategy that we are going to use here is that we will be picking up any two equations at a time. So we can pick either 1 or 2, 2 or 3, or 1 and 3. Whatever equation we pick up, and we'll need to find out the solution. And once we get the values of x and y, we'll be substituting that in the other equation, the third equation. If it satisfies the third equation, then we can confirm that a, b, and c are indeed coplanar. Okay, so let us begin by taking equation 2. So let's take equation number 2 and add it with equation number 3. So we have x added to x, so that's going to give us 2 times x. Then we have negative 2y added to positive 2y, so that's 0. And on the right hand side, we have 3 minus 1, so that's 2. That's going to give us the value of x as 1. Now that we have the value of x, we can find out the value of y. We can use equation number 2. So from equation number 2, we have 1 minus 2y. This will be equals to 3. Which gives us 2y will be equals to negative 2 and y will be equals to negative 1. So now we have the value of x and y obtained by solving 2 and 3. Now we will substitute this in equation number 1. Now from equation number 1, what we'll do? We'll go to the left hand side. So here we have x minus, then we have y is negative 1. So this is going to give us the value 2, which means that x equals to 1 and y equals to negative 1 is satisfying number 1. And hence we can say that the three vectors a, b, and c, these three vectors are indeed coplanar. So we have successfully verified the problem.